This talk and the JavaScript for WordPress Conference are brought to you by our sponsors at 10up and WP Buffs. 10up makes a better web with finely crafted websites and tools for content creators. Check out their junior and senior dev positions at 10up.com/careers. WP Buffs provides 24/7 fully managed support and white label agency services. Find out how they can help you focus on what you do best at wpbuffs.com/partnerships.
So what we're going to talk about today is the progress of JavaScript architecture. Now, as Zach said, that's a really big topic. So what I want to do is actually go into taking a look at what it solves and then taking a look at all of the different architectures that we have. So let's just go ahead. What I always like to do, if you're new with me here, is I like to cover what we're going to talk about and then the goals that I have set out for you. Okay. So let's see. What are some of the things we're going to talk about? We're going to talk about the what. What is it? Because the thing is, for us to be able to use it, we need to understand and have this definition of what it is. So therefore, let's start with a common understanding, and then we're going to go into the why. Why does it exist? And what are the problems that it's seeking to solve? And we're going to use those problems all the way throughout our entire conversation here together that you and I are going to have. We're going to look at the how. So we're going to look at different architectures, and there's a lot of them. Let me just tell you, there's a lot of them, but I picked out the more prevalent ones so that we can discuss and say, okay, how do these leverage to be able to solve the why? Okay. And then what we're going to do is we're going to score them. We're going to say, okay, how effective are these? Because as we start to progress, right, to where we were, to what's prevalent, to what's happening now, to what's coming, we can see how we're progressing to achieve and solve all those problems. Then we're going to talk about the future and look at what's next. Okay. And I'll give you some links that you can then go and watch some of these different conversations about all of this as well. So I'll ask you and challenge you to keep exploring. So the goals for you are going to be this. We're going to develop your architectural mindset. Okay. And that decision-making process. So the whole point of architecture is in that decision-making process. We're going to talk about that. And then I'm going to challenge you to think. I'm always challenging you to think. We're going to think about these key concepts and how they roll over into the way that you work. So let's just get started. All right. That's enough of the intros. What is software architecture? I want you to think about that for just a minute. What is software architecture mean to you? Okay. Now, I've gone out and I've asked some people over the years, and I've been doing this since the mid-1980s. Yeah, I know, a long time. And I've been analyzing how we use our architectures. And the answers that I get a lot of times, and I've just pulled out the three biggies that I get, are it's the file system structure of our code. Well, no, not really. It's the structure of the code itself. Well, yes and no, really, that's more of an implementation detail. And then I get this snarky kind of response when they think of an architect, right, the software architect, and they get this abstracted visualization of what the heck they're supposed to be building. Okay. So what I want to do is this for us. I want to frame this context to say, I'm not talking about what a software architect does. Instead, I want to talk about how architecture helps us or hinders us in our work, in the development work that we do. All right, so let's get to a definition here. If we go to Wikipedia, then here is what it says about it. I just took a snippet out. Software architecture is all about, now listen to this, hello, fundamental structural choices. Yeah, that's what it's about. That are very costly, and I put the very in there, but it's costly to change once it's implemented. Now, you're going to read this, and you might think to yourself, until we explore these ideals a little bit more, you might look at me the way my dog looks at me when I ask him a question. Huh? This isn't my dog, by the way. I couldn't get a good picture of him, but you get the point, and that it sounds like, okay, what does that mean? So let's break it down a little bit more. If we're looking at this image and we have a phone here, we can see that there's a blueprint, and then there's all of this virtualization of the different components that go into building this thing. then what we can start to realize is when we have a set of requirements, what is this project going to be? What is it that we're building? Whether it's a membership plugin, a form plugin, some sort of new innovative thing, maybe a marketing plugin, or maybe it's a project that we're doing. What are these requirements? How do we move from requirements to code? Right? There might be this propensity to say, well, let's just start working on the code. But what ends up happening is we can overbloat it. We can have a difficult time being able to wire things together. It can become very brittle, very hard to build, test, and maintain. So what we do instead is we stop and we plan. Yeah, so the architecture is right here in this planning phase. And we're going to go through what we're doing with that. And then that becomes the code. So we can think of it as that blueprint, where we're stopping and thinking about that structure, and we're making decisions about that structure and how we're going to actually implement it through our code. So software architecture is all about making decisions, and those decisions are going to heavily impact the code over its entire life cycle. So we'll be defining that blueprint of how we're going to build, what we're going to build, how it's going to work together. So there's going to be this emphasis on these things. Ready? All right, here we go. How all the pieces are going to interact. So if we sit down and we pre-plan this, then our task of being able to divvy up the work amongst our team and break down those pieces becomes much easier and manageable because we've pre-planned, oh, okay, we're going to take all these pieces and break them out, and here's how they're going to interact with one another. Here's the role that each piece is going to play in our system. That's important. And here's how everything fits together, but we've got one more key component to this. Ready? Over the entire life cycle of this code, and that is so important. It's not short-sighted on, let's just get it built and pumped out. There's a life cycle to this thing. So it's the big picture. And that's why Zach said he put me at the end here of this conference, is because it ties everything together. For us to see the big picture, then I have to challenge you to step out of the code and look at it from this 30,000-foot view of, wait a minute, I need to see all the pieces, which means I need to think in building blocks. I need to understand the problems we're trying to solve. I need to understand the requirements. I need to understand software principles. I need to understand design patterns. And then I start to break things down. What am I going to build, and how am I going to achieve all of these different results we're trying to achieve? Okay. Big picture. Got it? All right. Let's cover the why. Why does it exist? What problems does it seek to solve? This is how we answer the why, because it really gets down to what is architecture doing for us and why should we care about it? The number one problem is this: synchronized data. You might not have heard this term synchronized before, so let me share it with you. So I used to build a lot of real-time I/O systems. So if you can imagine a robot screaming around and moving, we had to be able to get that information very, very quickly so that we didn't crash anything, so that a vision system could pick things up and a robot could move. Okay. We then would use that information, and it needed to be able to propagate in real time so that it was real information. We have that same challenge today, don't we? With our front-end devices, so that when somebody is interacting with our app or our website, we need to then be able to think about synchronizing that data throughout the entire system. Okay, all the way through all the pieces of our app and into our state management. So Josh talked to you about that, but all the way through the whole system. Make sure that that data is true all the way through, and even when we're talking to the back end and that server. That's a real challenge. Let me tell you, that right there drives complexity, and we're going to see that as we move through this and how we solve that problem. Number two is performance. All right, well, performance has a lot of iterations to it. We can think about connectivity, right? So we've got to connect to the internet. So there can be some latency issues with that. There can be some intermediate type of problems with that, right? And then what happens when that occurs? There can be connectivity to external APIs, not only just to WordPress in your website, in your app, but also to external APIs. We have to think about it at the code level too, and make decisions about, wait a minute, what's more performant in the way that we build things, right? How can we tweak this out to get our scripts smaller and more performant, but also each of the elements that goes into our code complexity? Do we use this? Right? What's the big O of that? And trying to think about all of these things. Performance is also impacted by our scalability. So performance is very critical. And what you'll find with each of these problems is they all interweave. So performance can add complexity potentially, which can impact data, which can impact the front end and the user experience and so on. Okay, so we're trying to solve this as well. Developer experience, number 3. Okay, you and I work in the code. So therefore, when we think about our architectures, let's think about that. If it's too complex, if it takes us too long, if there's too many hoops to jump through, well, our developer experience goes down, right? Yeah. So rapid development. How can we reuse things? We want to be thinking about that we're loosely coupled. Right? We want to be thinking about software principles and how we can move those into our code to not repeat ourselves and drive up the human aspect. Okay. We want to think about performance, and we want to think about the long term of, wait a minute, I put this together, but somebody has to service it. And then what if we want to extend it? Yeah. Or a new feature, the customer comes along. How easy can we do that? So architecture considers that too, and how we can solve some of these problems and have a more delightful developer experience. Wouldn't that be lovely? User experience. Absolutely. Absolutely. To the user, what's important is that it's fast. They can rely on the data, that when I click something and I interact with something, that I get some result back, something I'm expecting, right? That we're delivering that user experience. So you can see how these all weave together. And so architecture is considering that as well. If somebody clicks on something and we're waiting for data and they've got old data sitting there, or there's some latency, well, it's going to drive down the user experience, isn't it? Yeah. Okay. So we consider that too. And then software is a business. So there are the business concerns that we need to think about. There's costs. Software is very costly over its entire life cycle, not only from you and your team that's putting it together, but also for the client who is now using the software. And we want to drive down those costs, cost of ownership, cost on our side. There's risk involved, right? So we want to drive that down. And then there's time. So we want to drive that down too. So as we're looking at these, we want to drive up the user experience, drive up the developer experience, drive up the performance, drive down the business. And then we want a very robust data synchronization system so that everything is synchronized and we have real robust data. By the way, data means state and data and all of that, some values and so on. Okay. All right. What drives our thinking and our decision-making process? So we covered the why, we covered the what. Now we need to start thinking about, well, how do we think about this? How do we make decisions? Okay. What drives our thinking and decisions is this: how all the pieces interact, the role each plays, and how it all fits together over the life cycle. I already covered that earlier. I just wanted to put it back up here for you again because it comes down to thinking about all the pieces and how they all fit together. That's what architecture is. The other thing is we do want to leverage software principles and design patterns. So it's important that you learn those, you know those. These are proven to really help you and I as the developers to be able to achieve these results that we're trying to achieve. So leverage them. All right. Other things that drive our decisions, and we've briefly talked about these, is remember, I just want to emphasize this, is software has a life cycle. Oftentimes we get short-sighted and we think about, oh, I got to get this built and shipped. But software has a life cycle. So we have to think about from day zero right here, right? The day that we start all the way through until it's retired, its entire life cycle. After you deploy it, through the time when the service team is taking care of it, through the time that we're going in and fixing bugs and we're extending things and adding new features and we're updating things, right? Until that software gets retired. So we have to think about it, not in a short-sighted way, but in a long-term approach. Decisions we make here are important. So what we're trying to do then, drive down cost, drive down risk, drive down time, increase effectiveness, which means, hey, did we achieve the results, right? That business requirements, did we achieve the user experience, the developer experience? We want to drive that up, keep maximizing it, maximizing performance. These are the things that are going to drive us over the entire life cycle. So I want you to be considering all of these in the choices you make, because I want you to think about this. Imagine you're developing some new plugin and you're considering what architecture and how to lay this out. Okay. Once you make that decision and you start implementing that decision, it becomes extremely costly to about face and change it. So it's important that we make very informed decisions and we know how everything works together. We know our intent and we lay that out to keep driving down those costs. Okay? All right. Let's talk about each architecture now. There are a lot of them, but we want to talk about them by how have we solved these problems over the years? And that's the reason why these different architectures exist. And then how effective are each one of them? That's important, right? So when you're trying to decide between X and Y, then you need to consider, well, this one does this really well, but it doesn't get you all the way as compared to Y. So let's get started. All right. The layered architecture goes back for as long as I can remember. So this one goes way back there. And notice that it's horizontal. Everything is horizontal. So we have the presentation layer, we have the business layer, we have the data layer. And we start to think about this type of architecture. And notice that the big fat business layer, where all of our business logic is at, where all the decisions and processing are at, sits in the middle, right? Okay, we can see that. So that the presentation layer, our views, can't talk to the data, our models. They have to go through that business layer. But here's the thing. I've seen this architecture a lot over my 30-some years in this business, and we don't build things this way. No, what actually gets shipped isn't like this, even when we say that we're building a layered architecture. So a lot of the architectures that we see try to solve that problem. So this one hasn't been overly effective for us, but some of the principles from it do get spattered and built upon as we go to the next. Okay, the MV architectures. This is probably ones you know, right? So we have the MVC. So the MV is model view and then something else, something that is the brains of it. Okay, that's an asterisk there. So with the MVC, we can look at this architecture and go, okay, I got a view, I got a model, and then I have this controller that sits in the middle and makes the decisions. All right, and you can see the interaction between all of those, but our roles are well defined. We have our separation of concerns. We have our separation of roles. It's decoupled, right? It's easy to break this up and disperse the work amongst a team. It's easy to say, no, you go build this, you go build that, you go build this. So it's very powerful, and it's been very popular for a long, long time, decades actually. And then we have MVP, which is the presenter instead of a controller. Okay, so it's just a different way of doing it here, where all of our data formatting is in that presenter. And then we have MVVM, the view model. Okay, and you notice it says there that we have state and operations going on in there. So we have that state management and so on. And then if we look at all of our frameworks, we have Backbone, we have Ember, we have AngularJS, we have Knockout, we have Vue. So we've got these dispersed, and each takes just a little bit different approach to it, but underneath, they're using these principles in this type of architecture. Okay, so when we think about this, how effective is it at solving those problems that we talked about? Well, I talked about some of the pros of what it does, and that's why it's been so powerful and has such longevity in our profession. But it isn't handling the synchronization of data. Okay, performance can be an issue because we can end up with some complexities and some bloat when we start to do this. All right. And yes, the developer experience goes up. I just talked about all those things. It gives us all of those cool things of separation of concerns, decoupling, and so on. The user experience, well, it doesn't care whether this is going to help us or not. And then from a business perspective, because we can divide everything up and we have clear roles and separations, absolutely, it has ticked that box for business. So then what we can see by looking at this is it hasn't gotten us all the way. And that's why we have some of the other architectures and the new ones that have been coming along. Now, I might blow your mind here with this, but I'm just going to put the slide up and then we're going to discuss. So MV plus REST, and we're going to talk about REST here in just a little bit. The combination of these just haven't solved all of the problems. Both are awesome. They are revolutionary in how we've put things together, but they've only got us so far. So because we want to solve all of these problems, we need to start thinking about how can we go and start maximizing all of those things that we want, right? The problems that we're solving, and driving down our costs and risk more. So why? Why haven't it completely solved our problem? Think about that. Why? Yep, you've probably heard this a lot. So if you follow JavaScript a lot, then there is a lot of conversations around mutability. Okay, here, maybe you don't know what this means. So I'm just going to go ahead and give you a definition. I'm not going to assume, but mutability is talking about data and that it is subject to change. So we talked about the synchronizing of data. Well, this is a big problem for us. Okay, because that synchronizing of data, we have to think about how reliable is our data when it comes time to process it in each pieces of our application. Okay, how long do we have to wait for reliable data? How long does the user have to wait for reliable data, especially when we're talking about the backend connectivity? What's old, what's new, and so on. This can cause us complexity too, because we'd end up doing things like, well, we have to check, did the data change? Maybe it's different than what we would expect, so we have to put checks in for that. We have to also do things like, hey, is this data refreshed or dirty? Right? So we end up adding complexity, or we end up having this complexity of trying to manage it in different places. So what we want is the inverse of that. Okay, flip it around to where we can say that data does not change. And there are strategies for that. I'm going to teach that to you, don't worry, so that you can understand how we can leverage immutable data. Flip it around. Okay, this is what we want to make sure that we have everything synchronized and we can trust the data that's there. Now, functional programming is all about that, right? Pure functions, it's data in, data out. There's no side effects, no globals. And we have that immutable data. But we can achieve this in OOP too. It's just a different way of thinking. And it's a different way of how we process. And there's some things we need to be able to do it. And we're going to talk about that too. Number 2, I talked about REST. That REST hasn't gotten us all the way there because we end up with this thing of overfetching. Now, let's just talk about that a little bit. So when we have multiple endpoints, imagine you start your project and, well, we just need this couple of endpoints. And then all of a sudden, before you know it, I need this one, I need that one, I need that one, and that one. And then also the packets that we get back have a lot of extra data, that extra unneeded stuff. Well, there's a payload to that coming to us, right? There's extra processing we have to do to pick out the pieces that we want. And that was something that Jason was talking about earlier today. So this is completely contrived. Don't hold me to this, but as you start thinking about it, you need some user information, and then maybe you need event information if it's a scheduler type of application, right? So, hey, I need to know for these users what's the event information, what's their payment information, and so on. And we start getting all of these multiple endpoints going on, and we pluck out pieces out of each of those. So when we look at that, we can say, wait a minute, that doesn't tick any of the boxes for us. REST has gotten us so far. It is awesome, but it can also add some complexity. We end up having more processing, more data than we need. We end up having more of having to go and say, hey, give me this data, give me this data, give me this data. Okay, and that could be problematic. We can do better. And there are some things that can happen. So I just want to recap and talk about that. MV plus REST is amazing. It's gotten us really far, but it just hasn't gotten us all the way yet. Now, there's another architecture I want to talk about, and that's the component-based architecture or some hybrid of that. So with a component-based architecture, we're starting to learn from some of the things that we got from the other architectures. But I do want to point out, in case you don't know this, component-based architectures, they've been around a really long time. Did you know that? Yeah, we're seeing them now in our new apps, our new frameworks, our new libraries. We're seeing those now. However, they've been around. Gosh, I think the first time I heard about them was back in the 90s on IEEE when there was a paper published about it. So they've been around a long time. Now, what we can do is picture each one of these boxes as a black box. They're a component. And inside, it takes care of itself. And then there's this well-defined interface of how everybody can talk. There's some sort of bus, a facade. There's the brains, the mediator behind it. And then what we see is each one of these components are self-sufficient. They're easy to integrate. They're swappable. That's a real key component to component-based architecture, is that I could say, I want to take this one and pull it out and put a different one in, and I can swap it in and out without causing work to the rest of the system. Also, if this one fails, it doesn't cause the rest of the system to fail with it. And that's why this component-based architecture came about. So we have this black box inside too, this encapsulation. That's not anything new, right? We have that in OOP where we talk about encapsulation. So we can see from this that all of our popular frameworks and libraries, Ember, Angular, Vue, and React, all use a hybrid of this. They pull out the component part. So when we're talking about components like in Gutenberg, and we're talking about a component itself as in a block, well, that's just a hybrid of this. In true form, everything in this system, in this architecture, is a component. Everything. Okay, so just so that we understand and have a similar language. Well, let's measure this one. Okay, we're still not synchronizing the data. It's not taking care of that. It can have some performance issues in there. Again, we're not dealing with that here. We are driving some state down in here. We're allowing this black box to take care of itself, and that's good, getting it closer. The developer experience comes up. Absolutely. Building components is fun. It makes sense too. From a user perspective, well, this doesn't really do anything for them per se. From a business perspective, absolutely. Absolutely. Imagine that you could say, I'm going to take, I've got I don't know, maybe 20 different components, I could say, here, 20 different people, go build your component. We have a well-defined interface and we know how everything talks. So from a business perspective, yep, ticks the box on that one. But it hasn't gotten us all the way there yet. It's just another iteration of it. Now, I want to introduce this to you, is that as we're thinking about new ways of doing things, these are old principles, old ideas. So we're engineering old principles in new ways while innovating for these new solutions. And we're going to talk about that. Okay. So lots of these ideas go way back. So I just wanted to point that out. That's why it's so interesting to me as I watch things evolve and how we build stuff. Let's talk about our virtual DOM and then this thing of incremental DOM. DOM diffing, the actual diffing part is not new, right? So diff algorithms have been around for a long time. You and I do diffing, and when we just do get, I want to see the difference in the commit from this one to where I'm at now, and I do a diff on it. These tree data structures are nothing new either. That's a computer science type of concept of how we break down information into these nodes, into these trees. So it's a data structure. But we've taken these and we've leveraged these and been able to introduce something new, a new innovation through virtual DOM and then incremental DOM. And we see these in React, Ember, and Vue. Okay. These tick all the boxes. Absolutely. We get faster updates with less memory. Much faster. Performance goes up, developer experience goes up. The user is really happy because boom, I get much faster response. And then of course the business is excited about it too. Now this is taken care of for you behind the scenes, but I want you to be aware of it. Okay. So we've got the virtual DOM and we've got the incremental DOM. Whew, had a brain kind of went somewhere there. And let me just lay this out for you. So from the diffing side and these two blocks, these are the same. At the top is the real DOM. In the bottom, we can just picture this as an in-memory representation of the real DOM. And we're tracking what's going to change here. It goes through a diffing algorithm here and here, but here's where it gets different. In a virtual DOM, we have some parsing that needs to happen. So there's an extra step here in memory that needs to happen. Okay. And over here in the incremental DOM, and you can go here to Google with this link here and go read more about it, as well as React has a new one too that's coming. But with this, we can see it skips that intermediate step there, one last step in the operation, hence incremental. Okay. What's happening is React has React Fiber that's going to be coming. That's a new reconciliation engine that they're developing, and that's going to be really cool. So we can see innovation continuing, right? So this is really helping us to tick all those boxes behind the scene. So you don't need to worry about it. It's happening for you. But when you're making decisions, architectural decisions about do I use this or that, you want to be looking at one that is leveraging this in-memory process, right? This diffing algorithm, and being able to leverage this is going to get a better experience much faster. All right. The idea of data does not change. Woo! Yeah, functional programming. This has been big in that. React, we have this with immutable data, right? It's not going to change. Now, this tends to blow people's mind about, wait, how can data not change? Of course, things are going to change. So we're going to talk about that. I'm going to get a little bit geeky with you. Woo, okay. So what it's doing is it's leveraging that data tree structure. Okay, so think in trees, leaves, and branches. And we're doing something called structural sharing, and we're going to go through that too. And then I'll share a link with you that you can go and explore this awesome presentation just on how this works. Okay, this ticks all the boxes. We get synchronized data. We can rely on our data throughout our entire application. Yes, we do. There's performance in this, in that structural sharing. We get a bump in performance. We get developer experience because now, hey, we have less complexity, less bloat. We can pull some of that stuff out. We get the user experience because users are going to be happy, right? They can rely on the data. And then, of course, the business is going to be happy too. Let's talk a lot about data. Okay, I'm going to give you some quotes. Let's go back in time to 1993. Woo, way back, right? And Alan Kay, the creator of Smalltalk, you can go read all about this, the early history of Smalltalk. And I just pulled out this little bit right here. The last thing you wanted any programmer to do is mess with internal state. I agree. If we can't count on state, how can we have expected behavior? How can we measure that? Right? We need robust systems that we can count on stability so that we can scale it, we can test it. Okay? We can take the checks out of our code. So, here's another one. I think this one hits the nail right on the head as we start talking about synchronized data and the difference between mutable and immutable. And we talk about why it's so important to think about how data propagates itself through our entire system. So, Ben Mosley and Peter Marks. Okay, let's go back to 2006 when we actually fast won, right? And you can go read this. I gave you a link here to the paper, Out of the Tar Pit. Here's what they said. And I put this emphasis in there myself. We believe that the major contributor to this complexity, now listen to this, the major contributor to complexity in many systems is the handling of state. Data. Right. Remember that was my number one thing was synchronizing our data. Yeah, that adds a lot of complexity. And it's been a problem we've been trying to solve for a very long time. And we see some solutions that have come along, and we're going to talk about those. We can see here they go on to say, and the burden that this adds when trying to analyze and reason about the system. It's hard to test. We have to put some code in there for complexity, right? The robustness goes down and becomes difficult to scale. We need to think about what state and what data is doing to us. And that's where this concept of having immutable systems comes into play. That means you and I, we need to develop and change how we think about the state of data. We need to think about it as a single occurrence. Once it occurs, we don't change it. Period. Okay. How do we do that? Well, first of all, this is a key thing I want you to think about is that we need to develop the way that we think about the state of data. Now, let's get into the details of it because I know the first time that this was brought to me, I thought, wait a minute, data does change. Of course it does. I'm going to click this. I need this information. Data is going to change. How can we achieve this without adding extra memory and processing? Well, let's get into it. All right. So let's imagine that I have this object and we can see I'm using these properties and it's just me. Okay, again, contrived, but here I might have a user ID. I have a first name, last name, role, Twitter, GitHub. You can see, right? So we have some keys and we have different pieces of data. Now, let's imagine that we're going to take all those pieces of data and we're going to horizontally represent them as nodes. So let's break them out like this. And what we have is this is the user. And once this user is created, these nodes do not change in memory. Okay, so up here are our pieces of memory, our node that's holding a value. And then it's keyed here by these properties. Okay, now imagine that you need to change something in this. You're doing some processing and you need to make a change. Of course, you're going to make some changes. Well, when that happens, you do not change this user, right? This particular instance of this data does not change in memory. Instead, you create a new representation of it. And now you make your change. Let's say my ID went from 1 to 10. And that's the only thing that I wanted to change. So we start to get into this idea of copy, don't change. Now, in your mind, you might be thinking, wait a minute, copying all that data, boy, that would really put a load on the front end, wouldn't it? Yeah, I bet you're sitting there going, well, of course it would. I've got double the data. I've got double the processing. When I think about how we iterate through a tree data structure, well, that's double. No, it's not, because there are lots of smart people that have been thinking about this. And what they did is they leveraged, now we're going to switch this to a trie, T-R-I-E, which really is pronunciated tree. Okay, but I wanted to give you the right term so that you can go and look it up. Plus structural sharing. Okay, with structural sharing, just think about, maybe you don't know with computer science or data structure that we break it out into nodes like this. Okay, and then we can go and iterate down through to be able to get to our data. But what we see here is this. Notice that we're sharing the structure. Do you see that? So the original user here, we can go down through the nodes. Here's the original information. Here's the unchanged information, and we can see the paths. And then with our new user, all that we had to create in memory was this new area for what changed. Yes, we'll pick up a second node here so that we can copy that over. But what ends up happening is we can traverse this much faster. What else happens? Well, it's less memory. But wait, there's one more thing. Can you see it? Think about it. Well, think about Git, right? Version control. What do you get with this? Yeah, you get the ability to roll back. Pretty cool, right? So by using this, we'll notice that each time the data change, we get new instances of data while retaining the old. So if we need the old, then we can use it. If we don't need the old, then we can go ahead and let our data store be able to say, okay, we're just going to let the garbage collector come and get this. But what ends up happening here, the advantages with this is it's less memory, it's more performant, data persists, right? So we can say, hey, my data is very robust. I can count on it. I can trust it throughout my system. And it ticks all the boxes here for us. Woohoo! This link up here, if you're geeky like me and you really want to understand how this works, then what I would suggest is go here and watch this YouTube video, because I found it very, very interesting. Now, the thing in JavaScript is there's not an immutable data structure built into it. We don't have that. So instead, right now, what we have to do is use different packages for it. So if we want to leverage this, yes, you can get some immutable right out of the box with React. But let's say we're using something else, or we want to do more. Then what we would do is over here with Immutable.js, we can use this package, and it's very JavaScript-like. Yeah, it feels like JavaScript. It's using the same conventions. We get a lot of different immutable data structures, lists and stacks and maps, order maps, sets, ordered set, and record. So we get a lot of different things. It really feels like JavaScript as you're using it, and it's extremely performant. And everything you want to know about it, you can go read about it. It's also on the React side of how to leverage it in. But you can leverage it into different frameworks too, just letting you know. Okay, so these are the two that are available right now on the market for you that are the most robust out there. So Mori over here, I don't think in our space we'll be using that quite as much. All right, so that's that closure script. We're not going to be using that quite as much. We're going to be over here in the immutable side. So then this has led us into a newly realized immutable architecture. And we're seeing this being very prevalent over the last couple of years. Okay, it ticks all of the boxes for us. Very powerful. So right here, when we're dealing with things like React, Redux, all of that, and there are others, we're using this immutable architecture and really leveraging in us. And when we bring in Immutable JS, that package into it, we can even realize and maximize the benefits even more. Woohoo! It's amazing to me how we've gone from that layered architecture through history, and over time, just like with anything, we keep getting better and better and better and better. Now, how about that REST thing we were talking about? How do we solve that problem of overfetching? Okay, well, Jason talked about it earlier with GraphQL. That right there, when we leverage that, so if we need to really maximize our performance at that point, right? And being able to go and get just the data that we want and minimizing our endpoints and pulling in only that information that we want in the way that we want it. Then what ends up happening with this is that, hey, our performance is going to come up. We're going to have less complexity, right? We get a better developer experience. And because we have this less data, less complexity, we'll get a better user experience. And of course, the business is going to love it too. So what we find is by doing all of these little things, which are all available to us right now, look, we've ticked all the boxes. Woohoo! Yeah, it's very exciting what you can do with architecture. You might be wondering, okay, well, what are the next steps forward? What else can we do? Because just because we tick all the boxes doesn't mean we're done, because we can continue maximizing that. Well, there was a talk this year. It was at React Europe that really got me excited. And I'm going to put this here in the slide because I think it starts to get us to think about what's going to be coming down the road and what we can be doing to continue maximizing this idea architecture by Lee Byron. We have the immutable, declarative, executable architecture, and he calls it the idea architecture. Man, go watch that video. Whew, that's a really good one. So with this, and I completely stole this from him and then put it on a different background screen. So I'm giving him the credit here for this. We have all of this available to us now, but when we get to the action side of things, we have that the server, right? We have to make a promise and say the state in that data. We have to say, okay, well, that we need to make a promise for because it's not instantaneous. When you agree? Yeah. So we're saying, hey, I need some information. I have to make a promise that that real information will come at sometime in the future. And then we have this, well, I have to make an optimistic guess about what the state is. How do we manage that? Well, what he's talking about here is we need this queue. Ooh, that's something that doesn't exist right now. But what it's going to do is keep track of these in-flight actions and manage all of that. And he has some ideas in that talk that if you're geeky like me, that you love architecture and you want to know what's coming on down the pike, go watch that, because that queue right there and this other future problem we're talking about here of server and making these optimistic guesses and managing all that in-flight actions before it comes back over into our state. Hey, this would be a solution. And he gives some ideas of how he's thinking about it. I can see this coming in not too far into the future. And when that does, wow, that is just going to keep driving us forward so that we can maximize the benefits. All right, let's just review these key takeaways for you. Okay, ready? Well, software architecture is all about making structural decisions, and you want to get it right up front because it's very costly to change your mind once you're in the thick of it or it's done. We want to think about the big picture and break it down into building blocks, and we want to think about all of the blocks, their role, their interaction, their relationships, and so on. Right? We want to make sure that we roll in design principles and design patterns into that too. Right? Use all those lessons learned. Think about reuse, all of that stuff. We want to make decisions that are based on synchronizing our data to make sure we have robust data throughout our system. We want to think about performance. We want to think about the DX, the developer experience, UX, the user experience, and the business side of it. Here's what I want to leave you with is we are very close to solving all of the problems. Very close. And when we use everything that I just went through today, you can see it ticked all the boxes. Yeah, that's a big point. The future is going to be about maximization, right? So the problems that we know about today is about maximizing performance, experience, and that data synchronization, driving down the cost and so on. So we want to maximize the solutions there. And then it will be about solving tomorrow's problems, the stuff we don't know about yet. Yeah, so that's what the future is going to hold. And it's very exciting to think about architecture because it drives what we build, how we build, and our businesses all the way down through the entire life cycle. I want to thank you for spending some time here with me today. You can find me here on Twitter. Come on over to Know the Code. You can talk with me in Slack if you have any questions or you want to explore this just a little bit more.
Thanks for watching this talk from the JavaScript for WordPress conference. If you're interested in more talks like this, head over to javascriptforwp.com/conference to see an archive of all talks, as well as information about upcoming events.